So our next presenter is Stefan Furey, who is the Nova Scotia Environment and Climate Change Program Lead for the on-site program. And he's going to give us a few updates from the department. So welcome, Stefan.
Thanks, Glenda. I don't have a lot this year, so it'll be a pretty quick update, but just a couple points of clarification that I've noticed over the last year. So the agenda today, I was just going to touch on some stuff related to ATUs, the certification, and a couple quick design notes. There was someone asked for clarification on distribution trenches in sloping sand filters. And then I have a couple slides about climate change resources. And then I thought I'd just leave a bit more time perhaps at the end for some discussion and a request to this group for future updates, things that maybe you want me to bring to the AGM. So on alternative treatment units, ATUs, what is a certified ATU? Get that question quite a bit. So as per the standard, there's three categories. So either they're certified under BNQ or NSF. BNQ is the Bureau de Normalisation de Québec, a company out of Quebec, obviously, that does third-party certification. And NSF is the National Sanitation Foundation. They are based out of the States mainly, but I believe they have or are opening up a Canadian testing site. And the other one is if it's approved in writing by the department. And we do have a list on our website. It's a bit shorter now. It used to have all the things. In 2016, with the introduction of the standard, we included these categories. So basically anything that has BNQ or NSF certification is automatically approved through the standard. If it's not, it would have to be on the list that's on our website. And if you've been attending the AGMs, you probably remember that in addition to sloping sand filters and their popularity, ATUs are also growing in popularity as well. I don't know if that's a nature of the costs coming down relative to sand-based systems, also probably running into a lot more confined sites that maybe need that additional treatment that an ATU can provide. But they're certainly on the rise in Nova Scotia from what I see in the numbers in our system. So next question is, well, how can I tell if it's certified? One, the easiest way certainly is to look for the certification mark. It's expensive to get these certifications, so certainly I would expect that the ATU manufacturers would be putting that picture and that text in their brochures. So you can also search BNQ and NSF websites for approved technology. The BNQ website, there's not a whole lot that is certified under BNQ as of today, but you can go on the website. It will show you which technology providers have been approved so far by them. NSF have a lot more. I've been on their website recently. They seem to have changed their search function. It's frankly a little harder to navigate, I find, but you can find technologies on there. It's probably easier just to look for the brochures, to be honest. You can also review our list that's on our website. So it's pretty limited now. Like I said, basically that list was scrubbed of all things that had NSF or BNQ certification because it was redundant, so it's a lot shorter. I do get requests from time to time of, well, can I get this approved? Generally, my response will be, well, you should be going through NSF or BNQ, or you certainly have the option to do something else, but really the level of effort and the rigor should be somewhat equivalent to what NSF and BNQ require, which is pretty substantial, to be honest. I had the opportunity to participate in a BNQ committee that was reviewing the standard. So they test the thing over the course of a year. There's cold weather testing, which is great for Canada, obviously. They have various stress test models like power failures and a vacation scenario to make sure that, the reality is sometimes homeowners can abuse their system, so they kind of work that rigor into their testing. There's been some confusion lately about various model numbers of a technology. So certain manufacturers will have different models, using the same underlying technology, but they may have a smaller residential module. And often those are NSF or B&Q certified. Then they'll have larger commercial ones that maybe are not. So some people have asked about that lately, and still trying to navigate that. We're seeing an increase in larger on-site systems too, wanting to use some of these larger ones. For now, I'm still relying on the NSF and B&Q certification. And when I'm thinking about, what an ATU is under the on-site program, I'm usually thinking about these smaller residential systems. I think, that's where the on-site program kind of grew out of. So a type of technology that obviously is certified, but that you would see in a smaller residential system. It's kind of pre-designed, off the shelf. You can take it and install it. The level of maintenance and oversight is kind of appropriate with, kind of a conventional septic system versus something like a sewage treatment plant where you kind of need a bit more of a day-to-day operation to keep that thing running well. But if you have any doubt, I certainly recommend just reaching out to the department and just ask. We can help you with that. So for some ATU design notes, this stuff is straight from the standard. So it must be designed so that treated effluent is discharged subsurface. We don't have a lot of point source discharges. It's still an option, but it would have to be done under approval, and we consider that as a last resort, and I think I've talked about that in previous sessions. So we certainly will push for something subsurface before we would consider any kind of point surface discharge. The other thing that I really want to point out here as well, in addition to being subsurface, that the infiltration area system for an ATU must be based on the native soil receiving the effluent. I've seen some applications where the ATU itself, or perhaps the dispersal bed for the ATU, will have sand underneath it or in it. And people have used the imported sand, or have attempted to use the imported sand as the basal area, but it's the soil under the sand that really should be. That's the native soil, and ultimately the effluent's going to go through the sand and hopefully seep into that soil. So you want to have it designed for that underlying native soil. And then I want to touch on loading rates. So currently the standard does allow for values in the manufacturer's manuals for loading rates for their ATU. If there isn't, the Table 9 loading rates of the standard must be used. So there are some ATUs out there that have manuals with loading rates. There are some out there that have manuals that don't have loading rates. If they don't, you must use Table 9. Regardless, frankly, for me, I would recommend using Table 9. I've heard from some industry engineers that, with some concerns based on loading rates they've seen in manuals, they're just going to default to Table 9. So as of today, there is the allowance for the manufacturer's manuals rates. Certainly my recommendation would be to consider using Table 9 as a minimum, just for an extra factor of safety. And I just want to also touch on systems that are designed to be at grade. So we've seen a couple systems that are meant to be on grade, perhaps because of poor soil conditions or depth to the limiting layers. It's really important that anything designed to be at grade, or if you're in areas of poor soil, that is how it's designed and built. So I've seen at least one example where that didn't happen and resulted in a failure. And I'd probably point back to if you participated, so we rolled out a selectable sloping sand filter. There were some sessions on that. And you can see in the sloping sand filter schematic and in the standard. The sand filter needs to sit on top of the native soil, and the toe kind of needs to be open so that in times of overload or issues that effluent will break out at the toe, which is not ideal, but will be better than seeping and backing up into the sand and creating issues there. And it'd be similar with some of the ATU designs that I've seen where some of the designs that might be on a soil that's not great have been kind of sunk down to create kind of a bathtub effect. And the problem there is, of course, you're going to have the effluent go through pretty quickly through the sand, but it may check up on that, you know, that silty material and then back up into the bed. And, you know, it can be an issue certainly for a disposal bed. It can certainly be an issue if you've got an ATU design that also sits on top of that, because generally they need to be unsaturated, and so you don't want effluent to back up into that and cause issues. So that's, again, that's something that I've seen in a couple design applications that as a designer of ATUs you want to be mindful of. And I think that was it for ATUs. So the second point is distribution trench clarification. So this is the picture from the standard of the distribution trench. And so the question was, does the bottom of the trench need to be level, or can the bottom of the trench be sloped to match the slope of the bottom of the sand filter? And the answer is it needs to be level. So, I mean, it's shown in the schematic as level. It's always been level. The reason basically is you want even distribution of the effluent as it comes through the gravel trench and hits the sand, because at that interface, you're going to have a biomat develop. And so if you've sloped the trench, it's going to preferentially go towards the toe of the trench, and you're going to have a bigger buildup there, and you're likely to see more progressive failure coming back up. I think also, you know, as selecting or designing a system, you need to maintain that 1 meter vertical clearance distance. So to make sure you're absolutely maintaining that, you want to, you know, go from the heel of that trench and go straight out. Otherwise, in theory, you could kind of encroach on that 1 meter separation. So anyway, that was a simple clarification. The bottom of the trench, even in a sloping sand filter, must be level. And lastly, I was just going to touch on some climate change resources. Pretty lightly, I am trying to get some, I've reached out to some colleagues in my department to present a bit more in depth at the AGM on some of the resources they have. And there's some pretty cool stuff that they're coming out with. You know, I've also seen some applications where they're right on the coast, and you've probably run into a few of them. It's just a lot of these old, undersized cottage lots that people may be upgrading or turning into permanent dwellings, and there's just not a lot of space available. And sometimes, you know, you got to work with what you have, but at the same time, there's certainly additional risk and growing risks that I think designers should be mindful of. And it's probably more for engineers, because generally this will be in situations where you're not meeting the required setbacks. But I mean, it's a fact that climate change is leading to more frequent, intense storms. There's more coastal flooding and erosion impacts. I mean, we're seeing that in real life. There's higher storm surges. Certainly in this area of the province, along the North Shore, we've seen a number of examples in the last few years. So if you're doing a design in these areas, there's certainly, you know, some additional risk that you should think about in your design. Now for QPs, you have to meet the setbacks, so you will have to have that 30-meter separation distance, so in a way that risk would be mitigated just through that, but still something to be mindful of if you're in the business of laying out perhaps a dwelling or picking where the system goes. There might be some obvious spots where the system could better go on the lot. So this is a slide just showing some impacts. This is impacts from Hurricane Dorian in 2019. And I mean, we've had Fiona since then. But you can see here on the left, you can see, I think, a wellhead sticking up. You can see the level of erosion where the top of bank maybe used to be, and it is now. And so I've seen some applications where, you know, people have tried to put a smaller sloping sand filter design kind of in that area between a road and the top of bank. Again, sometimes that's the best maybe you can do, although perhaps maybe a holding tank in some lot like this, which is actively eroding and maybe is susceptible for the next big Dorian or Fiona, might be more appropriate. Again, there's no hard or set rules here to abide by, other than I'm just trying to raise the risk and point out some of the resources that you can use. So some of the ways you can think about this in design would be coastal erosion. Obviously, if you know, you're like, okay, well, here's the top of bank. The best I can do is maybe 5 or 10 meters away. The next storm comes along, you know, that distance might be cut in half. So just something to think about. Really, mostly the thing you can do is maximize that setback as best you can. If you have outfall structures, though, you can think about that. Those may be, you know, ripped apart in a big storm. So thinking about that in your designs. Sea level rise. It can increase the water table in these coastal lots. So as the sea level rises, you get more seawater intrusion kind of in land below the water table, which can push the water table up a bit. There's some extra research going on through Dow on that now, but that can happen. So as a designer, you can look at some of the resources. You can get estimated values of sea level rise and perhaps consider adding that into your 1 meter vertical clearance distance. And then, of course, storm surges, which can cause inundation. So, I mean, you can have waves just completely inundating, flooding a septic system. So in these cases, you know, just trying to site the system as far away or in higher spots would be something to think about in maximizing those setbacks. So there are a couple available resources, and like I said, I'm trying to get someone to speak much more in depth on these at the AGM. But this is a resource on the climatedata.ca website, and it has sea level rise projections. So this is just a screen grab I took of the year 2050 rise projections, which I think would be, if you're designing a septic system now, would, you know, be in the design life potentially of that system. So you, if you go to the website, you can kind of scroll back and forth among the different timelines, horizon years, and then on the right here, it will give you the number. And I think if you scroll over a grid or a number, it will pop the number up for you. So if you're colorblind like me, you don't have to go off this colored chart. Another available resource is flooding projections. So this is, the projection available right now is the year 2100, which is probably a bit outside the design horizon of a septic system today. But still, I think it's pretty valuable information to think about. You can see in some of these coastal areas that, you know, half the lot is shown as flooding risks. So if you're laying out a septic system or a home or a cottage, I mean, it's probably an area, even though it's 100 years out, at least for a dwelling, you probably want to think about avoiding those areas and building and designing on that lot to account for those future risks. And that's it for updates. So yeah, if you have any questions on that material, I'd be happy to try and answer them. Or, like I said, if you have any ideas that I didn't talk about today that you'd like to hear about, I'd gladly, you know, want to take those and maybe bring those to the AGM and speak a bit more in depth. And just don't forget the microphone. We have a question up front here.
Just can you go back to the previous slide?
I'll try. Here we go. This one? So this is, again, just a screen grab of a specific part of the province. If you go into the map viewer that's on this link, you can go around to all the parts of the province and zoom in and see. You can zoom in a lot more than this, just to make it make sense. I picked this scale for this slide.
Anybody has any questions, we'll bring the microphone to you. Just raise your hand. And anybody on the webinar, if you have questions, put it in the chat and I'll read it.
Is there a chance you'd ever put like a delineator course on for the QPs?
Would the department do it? I don't. I'd have to ask the wetland person. My guess is that the department wouldn't put the course on and would refer people to the existing courses, like New Brunswick or Melanie might be able to speak better to what options are currently available. I will say that, you know, wetlands, flag wetlands is kind of a growing issue. We've talked about this in previous sessions about how all the good lots seem to be built out, and now we're running into more confined lots and running into more wetland lots. And so we've been trying to, working with the board, develop more training, maybe not at delineator level, but certainly trying to create more awareness and training on wetlands for the industry.
Well, maybe it could be like worked into like the further education for the newer guys getting into the QP course, right? Just so that it could be like added in or like somehow trained into it instead of like learning later.
Yeah, I agree. And we made some, again, working with the board, we tried to update the installer course a bit. I think there's still some work to do there, but one of the things that we added in was specific slides to on wetlands. Now, you know, the delineator course is, Melanie, is it a week?
I believe it's a week. It was always a week when I taught it here with Nick at Fern Hills Institute, but he stopped doing it as he's now with the Biosphere Reserve. Derek's course through MCFT is probably also a week. And I know, like, the wetland specialists, I haven't asked them specifically about whether they would put on a training, but I doubt they would have the capacity. They have a hard time making it to the trainings that we provide, even for a day or so, to, yeah.
Yeah, so I'd say, you know, working in a delineator level course probably wouldn't be viable, but certainly working in some information and awareness, perhaps a one-day course could be an option. Certainly would recommend that people in the industry, engineers and QPs think about that.
Like, is there a way that we could like make it so that it's like there's a training course here so that we don't have to travel to New Brunswick to learn it? Or
Yeah. I'll take that away. I'll see what can be done.
Yeah, we've actually talked with MCFT about offering a course here in Nova Scotia, whether they get the Boreal team from New Brunswick to come here, or whether Sarah and I, who teach the wetland functional assessment, like we could do it. It's an option. We're talking with MCFT about it. So keep an eye on it. But yeah, I agree. Having that built in some capacity, whether it's awareness, just awareness, that's helpful. But if we could do the delineator course here, that would be even better.
Just getting these guys over here for 1 day is a lot, right? So traveling for 5 days when, you know, we got sites, customers, just thought.
It's a good idea. I'll take it away, and I'll talk with our wetland specialists, and perhaps Melanie, I'll reach out to you. I mean, certainly, I think things can be done. Keep in mind that it has to be done during the growing season, so, which is your busy season as well, but anyway, we can. Yeah. Yeah. All right, well, thanks, everyone. And I'll be sticking around for a bit after, so if you have any individual questions, feel free to come up and track me down.